So when we did this one, I get 1 over cos minus cos 10 squared over 1 equals cos. Let's do another one. Let's do number D. So still trigonometry. Identities, yeah? And we are proving. So we must prove that 2 sine... Oh my word, sorry. 2 sine theta cos theta over sine theta plus cos theta equals... Why theta already use so? It looks so weird. This must equal sine theta plus cos theta minus 1 over sine theta plus cos theta. Okay, so the general way to think about these is like it is said here. Like Mook in this guideline, eh? Choose either left hand side or right hand side. I think we did that with 2 examples, Mawa. And secondly, you can simplify both sides until you feel they look the same, and always use your quotient and square identities when it's necessary. So, okay. We can start with we can take right hand side, and say that it equals sine theta plus cos theta minus 1 over sine theta plus cos theta, and I guess we could multiply that by sine theta cos theta. We can do this. Times sine theta plus cos theta minus 1 over sine theta plus cos theta times sine theta plus cos theta. Oh, it's supposed to be sine theta plus cos theta. Yes, to keep it consistent. So we're not really changing anything, we're just multiplying the terms that we have by 1. And this gives us sine squared theta plus 2 sine theta cos theta plus cos squared theta over sine theta plus cos theta minus sine theta plus cos theta over the same as that, which is sine squared theta plus 2 sine theta cos theta plus cos squared theta. Do you see how this was derived? This was worked out. How was it worked out?
You multiply the numerator to sine theta multiply by sine theta. Then of it multiply the cos theta. Then of it no, is it kidding?
When you factorize or you multiply factors, if you have a plus b times a plus b, that equals a squared plus 2ab plus b squared. That's this is the same as that, it's the same as that. Then we can continue. Sine squared plus cos squared is a identity. So we've got 1 plus 2 sine theta cos theta over sine theta plus cos theta minus sine theta plus cos theta over, I guess, the same. Okay. It's easy to see that this could be that and this could be that denominator. I gotta start with the right hand side. So this could be the numerator there and this could be the denominator there. But what do we do with this one? Because we have this. And secondly, what goes on with this one? Is there someone joining? Stay in the call in case someone else shows up. Okay, that's backing up nicely. Then, oh snap. Where is this? Yeah, so we can change the slide there. Change it there because I'm not doing the slide. I just want to reference this. It's the same thing, it's just in reverse. So 1 plus 2 sine over sine plus cos. Okay. So 1 plus 2 sine theta. I'm not changing anything from the last part. So it's sine theta plus cos theta minus 1. Oh, it's sine theta plus cos theta over 1 plus 2 sine theta cos theta. If we add these, this would be sine theta plus cos theta, 1 plus 2 sine theta cos theta. So that goes into that once. Ooh, this gives me squared, and this goes into that once, and this is sine theta plus cos theta squared. We'll have to start this again. There's something I didn't do right. I can sense because it's not going to where the answer is. Let's start again. Number D says 2 sine theta cos theta over 1, no, sine theta plus cos theta, and this equals this sine plus cos theta minus 1 over sine theta plus cos theta. If we take the right hand side alone, that equals sine theta plus cos theta minus 1 over sine theta plus cos theta. What if I just multiply these two by the identity, such that it's sine theta plus cos theta over sine theta plus cos theta, and maybe we don't change this. So let's say we don't change that. Oh man, And now my nose is leaking. Okay, so this becomes sine squared theta plus 2 sine theta cos theta plus cos squared theta, and this is over sine theta plus cos theta plus 1 plus cos theta. So do you see how this part here, we just multiply this one guy that. This is going to give us an identity matrix and a part of what looks like that. And that still allows us to keep the same denominator on that end. And then we're left with that. So what then happens is this is identity, square identity. So it's 1 plus 2 sine theta cos theta over sine theta plus cos theta minus 1 over sine theta plus cos theta. You are going to hear how silly the answer. It's going close to the left-hand side. Can you see? Our right-hand side is getting closer and closer to looking like something on the left-hand side. And how do we see that? We've got the same denominator, so we can just add or subtract the numerators. And what happens there? We've got a negative 1 plus 1, so we're just left with 2 sine theta cos theta over sine theta plus cos theta. And that equals left-hand side. Okay, so that's how it's solved. So basically, here, the mistake, I'm going to use a red pen, was to include this. This was unnecessary. So this part was unnecessary. Could have just done with just this part. So just this part is okay. Just this is okay. Yeah. And even though I know, because I've done it before, that this is a double angle identity, we're not allowed to use it because we are not there yet. And even if we used it, it wouldn't really do much for us because we don't have a double angle anyway here. So that's why we can do without the double angle identity. You know the double angle identity, Tiger? You don't know sine 2 theta equals 2 sine theta cos theta. That's double angle. What does the word double mean?
Two.
It means twice, okay? Yes. Now you can do the other slides. Okay, so we can look at number E as well. And E on again, cos of beta over sine of beta plus tan of beta multiplied by cos of beta equals 1 over sine beta. Let's start with left-hand side this time around. It seems like it'll be fun to solve. We could still do right-hand side, but let's start with left-hand side because it would help if we reduce it. So we can say cos beta over sine beta plus, remember tan is a quotient identity. And this is multiplied by cos beta. Then this becomes, if we multiply there, we get cos squared beta over sine beta plus sine beta this gives us over sine beta cos squared beta plus sine squared beta. That's a square identity, and that's 1 over sine beta, which he calls right hand side. Does it look like magic, or does it make sense?
Because this one.
Where do you think it went? You're doing grade 11, you said no.
Oh, okay.
Where do you think it went? You did agenda. What happened to it? What happened to the Cosby? Explain to me.
This one. Can I also multiply?
Okay, let me ask you this. What happens if you multiply this fraction with the Cosby, and what happens when you multiply that fraction with the cos beta? What happens to them? Yeah. Let's say or multiply a cos of beta divided by sine of beta ka cos of beta. What's the answer? Okay, so the answer is cos squared beta over sine beta. Yep. What happens when you multiply sine beta over cos beta ka cos beta? What's the answer? Let me make it simple. It's cos beta over 1 times sine beta over cos beta. What's the answer?
How do you multiply?
I multiply, yes.
I think maybe. I guess in a lela. You guess like.
Don't guess. Explain to me using the math concepts that we know. When I multiply the fraction sine over cos by cos over 1, what's the answer? What do you get when you have a over b times b over 1? What's the answer?
Maybe b a over b squared.
No. You are wrong. Yes, Asio, you are wrong. It's okay to be wrong. We'll correct it again.
Okay, let me see.
Being wrong, as I say, just means you're incorrect.
A divided by b.
I say what?
A b divided by b.
No. So your fundamentals, shall multiply the fraction, you don't know that. That's what it means. It's okay. When you have a fraction and you're multiplying like this, these are multiplicative inverses of each other, and the answer is simply A.
Oh, okay.
This, where did you learn this? In which grade? 8, 9?
Yeah.
Yeah.
Okay.
It just takes a different form as trigonometry. Same thing. Same medicine, different bottle. Ke bupi ba itau, but bupi ba itau la ga change packet right dia e sa le bupi. O rega bottle of mayonnaise across and Blackwell boxer. It's the same as bottle of mayonnaise across and Blackwell Woolworths. Same thing. Same thing. So where did that go?
This one. It can't this one.
Yes. And where did this? What happened to this?
Which one?
What happened to this? Yes. You see? Yeah. So these things are ithutelo skolo, and that's the problem with many learners. Just wanna pass the grade to happy. I'll run. Just wanna pass. We're happy. It's fine, there's nothing wrong with that. I want to pass, but do you understand what you are learning? That's the important thing. Yeah, so the father's why is stressing. When I pass in, the teacher paying more on top of school fees. Country, the tutor level. Magdalene. The senior child is what? But it's fine. Now I'll receive if you want me to assist at a fee. Now I'll receive. But do you understand now where that process goes? At grade 11, at grade 12, the expectation is that you are supposed to understand how to multiply these by inspection. Calculate. 2 reasons are important for that, or a few reasons, let me say. The first one is, and I'll go back to this metric example. It saves you time, because when you the time you take to write, some of us are slow writers, so you take time. If you're supposed to answer a 3-mark question in 3 minutes, you're not supposed to take 4 minutes. Question paper is 150 marks, 3 hours. How many marks per minute? It starts there. So that's why these don't need to write down every single step, because it is assumed you did it 3-4 grades before, and then you have learned it well enough that you are supposed to just know how to apply it without writing it down. It's called inspection. So this one, 4 marks. You're not supposed to take more than 4 minutes on it. This one, 7 marks. You're not supposed to take more than 7 minutes on it. These are things you must know when you're preparing for an exam from beginning of year, every grade. Not just 2 days before the exam. Ragwana Magdalene. Yes. You ask yourself, can I do this in 7 minutes or less? And these are the tricks. Do it in your head so that you just write. You also improve your confidence and your memory and your retention and your problem solving skills. Agree? Yes. So that's why I skip some steps. I'm not skipping them. In my mind, they're calculated, and the assumption is you are also able to do that at your end. So you must practice these things if you really the learning guys, grade 8 and 9, Johana. Look at these, they are in that textbook. Study them if you really Yes. Alright. Anything else, Kushishimu?
No.
Okay, what happens here? What happened here for us to get there? Do you think you can show the step-by-step process of how to add these 2 fractions? Yeah, can you do that yourself? That's what I'm interested to know. Can you add these 2 and get to this answer on your book? Show me. Show us. Add those 2. Okay. No. It's not sine squared. It's not sine squared. It's just sine beta. That's why it's correct, because you're gonna get the rest of the thing incorrect. So it's not sine squared. It's sine beta. Okay. Yes. Always look at the detail. The devil is in the details. Do you know that saying?
No.
The devil is in the details. There are small things that are either done or said that if you pay attention to, they tell you what's going on. So sine squared it, I see your number A equals square fail. Add these 2 like you would fractions. I want to see if you know how to add fractions to whole or natural numbers.
I can think of idea.
You're just looking at the problem. You're not even showing that you're attempting it. Like you wanna go you are.
I can think of idea.
There's at least 1 or 2 steps between here and there. Do them. Show me there. I want to see that.
Oh, no, this keep
Okay, because that's what you're supposed to do. So I want to see that you understand how to get to them by doing it yourself. Arbon. How do you add fractions to numbers is what I'm testing. No swearing in my class, no?
Huh?
No swearing in my class.
How many steps?
It's either 1 or 2, but you're supposed to know how to add fractions in grade 11. Whether it's 1 over 2 plus 3 or A over B plus C, you must know how to add those. Ne? There are at least 2 ways to do this that I'm asking you. At least 2 ways that I can think of. At least 2 ways. Take as much time as you need, girl. But the point is, I want to see, do you understand what you have to do to add those fractions? Doesn't help you if I do the addition of the fraction. It's on Jamboard, you've got access to it, but you can't do it. It means you're gonna come back to my service again next day, which is fine. Like I said, I will receive, but are you learning is my concern. You don't know how to add fractions like they do.
Yeah. Cross multiplication.
You can't cross multiply, it's addition there. There's no cheat sheet. No, you're supposed to use the math principles to solve it. There's no cheat quick school. Use the math that you've learned in earlier grades. There's no quick trick. Back to basics. How do you add a fraction to a non-fraction? You don't have to be so violent with the eraser, Yes, and I see you often use a pencil to write. Why? Are you not confident in your answers?
No, like spelling
Inge? Fella ink.
Yeah, I think one of the notes like a
Pencil. Alright, tush, because you're struggling, yeah? So we're gonna make this simple by explaining the math from back where it comes from. Level screen. You've got x 1 over x plus x. What's the answer? How do we add those two? Unknown, unknown. You can't cross multiply, but you have to add. How do you add these two? Do you know? You don't know, ne? Right. This is how you do it. You look for the lowest common denominator. What's the lowest common denominator? It's 1 times x. How many times does x go into 1 times x? It goes 1 times. 1 times 1 is 1. And how many times does 1 go into 1x? It goes x times, and x times x is x squared. And the answer is therefore 1 plus x over x. Sorry, 1 plus x squared over x. How do we know that this is true? When we have a common denominator and an addition sign at the numerators, we can separate the fraction around the denominator. So in other words, we can make this its own fraction and we can make that its own fraction. But we do that whilst keeping the denominator intact, because we will have 1 over x plus x squared over x. And what this means is that you have 1 over x, this goes into that once, plus x. Does it make sense? Mm-hmm. It doesn't look like it's stuck. So we're going to do another one. You've got 1 over 3 plus 3. How do you add it? The lowest common denominator is 3. How many times does 3 go into 3? Once. 1 times 1. How many times does 1 go into 3? 3 times. 3 times 3?
9.
And then you get 10 over 3. And what's the answer? It's 3 and 1 over 3. Which you could have gotten if you had just said 3 plus 1 over 3 equals 3 and a third.
Okay.
Where do we learn how to add fractions like this? Which grade?
Grade 8.
Grade 8. You see how the things we learn every day add onto each other. That makes the difference between when you're a child and when you're a grown-up. You develop the knowledge by going from adding numbers to adding unknowns to adding trig identities. Because that way, as your body grows as a child and your mind grows as a child, then your mind, how we root these tricks and then you learn these things and they become easier as you ascend the grades.
Okay.
We're doing the same thing from grade 8 here. Same thing from when you start high school, you're just packaging it different. And all there is that they're testing you. Do you identify this is something you learned when you were younger? It's just packaged different. That's what they want to see. There's no trick, nothing. It's just what it is. Were you able to learn this in grade 8? That's all they want to know. So assembly is still a struggle here. Fine. But what you must do is go to classroom, download those grade 8 learnings notes. And after downloading them, study how you add these fractions so that you are good at it, and then see if you can't do the same with these things that they're not really 3, that's obvious, but they're it could be a number, it could be a decimal, but either way, you have to know how to add this as a fraction just as you would a fraction that's numerical. This is arithmetic, this is algebra, and the slides before is trig, but we're doing the same mathematical practice. So you're not supposed to struggle with adding fractions like that in grade 11. But I'm glad that we have identified it. Now you know what you have to do. So after we study here, when you do your self-study, if you want to improve outside of my time and your time to study, you must make your time in school. You must make your time to study on your own. And that's where you look at these things that you don't know and say, do I know this? Can I practice it? Where do I practice it? And again, you're more than happy to drop me a mail and ask me where in a grade 8 book can I find this if you can't find it yourself. But the books are there. Find them, learn them. You can do self-study. And this is also preparation for your university culture, because you have to learn to study on your own. I want to push. I get it? Yeah, you must embrace that. Right, grade 9. I guess A is paper 1. Just want to see some. Actually, I shouldn't open it there. I should just go back to my downloads. I want to see something. Is this maths? This is science. Right, whole numbers, fractions, decimals, what. You can go to fractions, 39. All of this. Yeah, if you don't understand how to do it here, trick, it's okay. Go back here. Fractions. All the concepts you need to solve basic things, they're here. Yeah? Fractions, yes, there we go. Equivalent fractions. Okay, converting between mixed numbers and fractions. Adding and subtracting fractions. So part 3.2, page 45 of your grade 9A maths learning guide. Cheer, né? Make time, go through this learning guide. This is what you have to do there. Yeah, another way, by the way, you can think of another way, which we did last night, is to say, I don't need this. No. Is to say, if we have cos squared of beta over sine beta, it's plus, ne? Plus sine beta. How would you make this one that doesn't have a denominator have a denominator that's common to this one that has a denominator? How would you think about doing that? Another way to solve this part here, we can put a question here. I want this one to have a denominator also on a lee. It's not a fraction, it's kind of a fraction, but it's like sine beta over 1. But instead of ebe sine beta over 1, ebe something over sine beta. How would you get that to be like that? That's what you ask yourself. And the simplest way to do that is I can multiply this sine beta ka sine beta over sine beta. Again, I said this last night. This is 3 over 20 plus 2 over 5, right? 3 over 20 plus 2 over 5. I want this 2 over 5 to have the same denominator as this one that has 20. What do? I can multiply 2 over 5 by 4 over 4. I didn't really change it. I'm just manipulating it so that this denominator can be the same, then I can add. And what I'll have is 3 over 20 plus 8 over 20, which is 11 over 20. You see? You multiply this so that it has the same denominator as that. Then you can just add or subtract the numerators because the denominators are the same. And what happens is cos squared beta over sine beta plus, then this becomes cos squared beta over sine beta plus sine squared beta over sine beta. Now the denominators are common, lowest common denominator. You know that phrase, LCD, Shion, LCD. Now we have that lowest common denominator. So now we have cos squared beta plus sine squared beta over sine beta. And since we have a lowest common denominator of sine beta, and we also know we've got a square identity, then we can simply say it's 1 over sine beta. Another question could say, prove that this can equal 1 over sine beta. Or something. But the point is, same tricks from grade 9, how to add, subtract fractions and don't. You also apply them in grade 11 trig, which counts for a lot of marks in grade 12 trig, by the way. As you can see here, you will get a 7-mark question that looks like this. Prove that so-so equals so-so. I'm not going into the grade 12 ones because we haven't learned some of the trig identities that are needed to solve these. But I'm just showing this is how they show up. Yeah, this is how they show up, man. So Gahpela, remember these things, how to add fractions, and practice them. Your fundamentals, your basic things from like your very early grades are your best tools to even doing your best in your grade 11 and 12 maths. Alright? Same thing, grade 9, applying it in grade 11 2 grades later. So at this point, I believe you'll have to decide how you're going to go forward with practicing and improving your maths game. So let's move on to the next problem. Let's do F. F for Ilkangaling. It's 1 over it's 1 plus sine. 1 plus sine of theta, and then this is added to 1 over 1 minus sine theta, and we must prove that it equals, why do they have D here? Okay, maybe let me put the D aside. So let's just say 2 tan theta over sine theta cos theta. Yeah? We'll start with, let's take right hand side. So it equals 2 times tan of theta over sine of theta times the cos of theta. We know that tan is a quotient identity, so it's sine theta over cos theta. And we can simply say that this is 2 into sine theta over cos theta multiplied by 1 over sine theta times cos theta. Then this becomes 2 times sine theta times 1, I guess, over sine theta times cos squared theta. These two are going to give us 1. So we only have 2 over cos squared theta, and this equals 2 over 1 minus sine squared theta. And this is a difference of 2 squares. 1 plus sine theta, 1 minus sine theta. And if we have a common denominator, this can simply be 1 over, no, wait, I'm wrong. Oh, okay. Let's try that one. I want to see something. If we have 1 over 1 plus sine plus 1 over 1 minus sine theta, that can be, oh, we can do this, yeah, I guess. 1 plus sine theta, 1 minus sine theta. Then this goes there into sine 1, okay, this, oh, no, 1 minus sine theta plus 1 plus sine theta. These are additive inverses, so you're left with 2 over 1 plus sine theta, 1 minus sine theta. And I guess if you go straight from left hand side equals, or rather, let me do this. So you can say left hand side equals, so this is that case, yeah, here in the matric learning guide where they say if both sides look difficult, you can simplify on both sides until you reach a point where both sides are the same. So on our right hand side we got to this point, and on our left hand side we got to that point. Therefore, and another thing, you'll never do maths without writing a problem down and thinking about how to solve it and solving it. You will never solve maths by just looking and say, yeah, they are the same.
No, that isn't like saying because can you go till it then you can one.
It's fine. But yeah, just be on the lookout for those things. This is how we can think about these. Alright. So here we used quotient identity, and here we used square identity. The same two trig identities we learned. One. I don't like how this mouse is slow. And the last one is, yeah, so that D was not necessary. And the last one, which is G, okay, 1 plus tan squared alpha, close brackets, multiply by cos alpha, and elegantly 1 minus tan alpha, right? Sorry, divide by 1 minus tan alpha, and it equals 1 over cos alpha minus, oh, it's sine alpha. Okay, then we can simplify left hand side again and say that this 1 plus tan squared x, or alpha, let me use alpha instead, times cos alpha over 1 minus tan alpha. And we can use quotient identity for tan, and this gives us 1 plus sine squared alpha over cos squared alpha times cos alpha over 1 minus sine alpha over cos alpha. And these give us 1 plus sine squared alpha over the cos of alpha. Oh, it's supposed to be this times that and this times that. So here we must have cos alpha. My mistake. And I would rather much at this point say that this is divided by 1 minus sine alpha over cos alpha. Then if I look at this in here, I've got something over cos alpha. Cos alpha, that gives me sine squared alpha. But here, 1, and then this gives me cos squared alpha. And then I still divide by here, and this gives me cos alpha minus sine alpha over cos alpha. Right? I'm still saying divide by, that's square identity, 1 over cos A. And this becomes, I divide by a fraction, so I multiply by the inverse of the fraction. If you're not sure how that's done, I believe the same grade 9 learning guide will tell us. Adding and subtracting fractions, multiplying and dividing fractions. Alright? So dividing fractions. So if you want to find out or refresh how to divide fractions, these pages, page 50 to 51 of grade 9 textbook will tell us, but we're back here. So since I'm going to multiply by the inverse of the original fraction, so it's going to be 1 over cos alpha multiplied by cos alpha over cos alpha minus sine alpha. And these are in multiplicative inverses, and this becomes 1 over cos alpha minus sine alpha, and that equals right hand side. It's clear, ne? So far, are you okay? Would you like to have something to drink, like water? Okay. You are sharp. All right. All right. So the next thing about trigonometry that we have to now look at is reduction formulae. The word reduction means to reduce, right? And in this case at trigonometry, we have a trigonometric function whose argument, so in other words, whose angle is a compound angle of either 90 plus or minus theta, or 180 plus or minus theta, or 360 degrees plus or minus theta. So in other words, instead of just having an angle theta, we now have cases where the same angle is 90 degrees plus or minus theta, 180 degrees plus or minus theta, or 360 degrees plus or minus theta. Now we must reduce this compound angle and reduce it. So let me just write the reduction. And I wish Narusha could be attending, because I believe she would really benefit from this. I don't know if Musa would benefit from this, but I know other learners which would. But anyway, so compound reduced So we reduce a compound, and we must reduce it to compound angle gets reduced to just simple angle. We'll call it simple angle for lack of a better word. All right, and then here there is a bit of an investigation we must look at. So we're going to start with 180 degrees minus theta on our Cartesian plane. There's x, there's y. This can be our angle. If we have 180 degrees and we subtract an angle of the same magnitude as theta, then we are somewhere here in this quadrant. Ne? And if we have 180 degrees plus theta, then we are somewhere here. And here we can have 360 degrees minus theta. And this side we can have 360 degrees plus theta. Again, this is also 90 degrees minus theta. This is 90 degrees plus theta. This could be 270 degrees minus theta, and this could be 270 degrees plus theta. Either or, these ones are value 90 degrees. They'll always change to co-functions of the function that's given with this argument. Yeah. So we're gonna start with 180 degrees minus theta, and it starts here. So we've got a xy plane. X, Y, and we've got an angle there, and the point P. Point P is the square root of 3, 1. So square root of 3, 1. And this radius is 2. There is theta. Ne? Right. Alright, so the line OP, we'll call this O and that P. The line OP makes an angle of 30 degrees with the horizontal, right? With the x-axis. And then we are also told that there's another point. Do you know what the word symmetry means? Eh? Do you know what the word symmetry means?
Symmetry, yeah.
What does it mean? You're kind of almost there. It just means so when you look at your face in the mirror or your pass, if you take a mirror and you put it halfway through, the half of the face will reflect onto the mirror. Sort of like how your hands are. This is a mirror reflection of the other palm. So in between them, where that reflection happens is the axis of symmetry. Yeah, so symmetrical means on the opposite sides of the line of symmetry, you get the same thing. So it doesn't necessarily mean cut in half, even though that axis could be cutting something in half. But it just means whatever you find on the one side of the axis of symmetry is reflected on the other side. Yeah. Alright, so the point P is at negative square root 3, 1. And it's a mirror reflection of point P. Ne? Now, in this investigation, we can do our definitions for sine theta, cos theta, and tan theta. Ne? And since we know that the radius is the same in either case, by the way, this is a special triangle here. So we must write down the values for sine, cos, and tan. So let's start with about the point P and about the point P prime. I'll use green since we're using green there. So sine theta for point P is going to be opposite over hypotenuse. Which side is opposite? It's this side, I guess. Yeah, so opposite would be, and how long is it? It's 1 over 2. That means here it's also 1 over 2. If you look at cos, it's going to be square root of 3 over 2. But this side is going to be negative square root of 3 over 2. And if you look at tan, it's going to be opposite, which is 1 over adjacent, which is square root of 3. And this side is going to be 1 over negative square root of 3. That one. Now, if we look also at the following angle here, we know that this angle measures 30 degrees, right? If that angle equals 30 degrees, what's the size of this angle here? If this straight line gives us 180 degrees, and we want to come to this line, how much do we subtract there? Because it means it's this angle here. That means we have to take 180 degrees and subtract a certain measure. How much is that measure? 30 degrees. So this angle in yellow is going to be 180 degrees minus 30 degrees. And we can, from the investigation, say that, 180 degrees minus theta puts us in this quadrant. If the measurement of theta in the first quadrant is known, then 180 minus theta would put us in the second quadrant. And this also confirms cast, where our trig ratios are positive. So since it's cos and secant, all the trig ratios, sine and cosec, and tan and cotan, then sine seems to be the only one that's positive up in here. Sine is the only one that's positive. You see that?
Yeah.
All right. We can do a similar investigation for quadrant 3 and quadrant 4. That one. But if we do the same with 180 degree minus or similar procedure, we'll then find which ones are in Ntwenani. Alright, so we can use the coordinates of P prime here, this one, these coordinates, to determine sine of 180 minus theta, cos of 180 minus theta, and tan of 180 minus theta. So how are we going to do that? We can say if 180 degrees minus 30 is this angle in yellow, if 180 minus theta is that angle there, then the trig ratio is going to be defined as so if we are using the coordinates of P prime to determine sine of 180 minus theta, then it's going to be 1 over 2 there. Then cos of 180 degrees minus theta is going to be negative square root of 3 over 2. And the cos of The tan of 180 degrees minus theta is gonna be negative 1 over square root 3. That one. Then what this means is, if this is the case, then tan of 180 degrees minus theta must equal negative tan theta. And here, if cos of 180 degrees minus theta equals negative square root of 3 over 2, then this cos of 180 degrees minus theta must equal negative cos theta. And in the same breath, then sine of 180 degrees minus theta must equal sine of theta. So when we reduce our angles from being compound to being simple, then we'll keep these conversions in mind. So keep this conversion, and that conversion in mind. That one. And in the same way we prove this, we can prove the other reductions as well. Alright? These problems, they also go for a lot of marks in grade 12. A lot. Like here, 8 marks. Why? Because you have to reduce from 180 degrees to 180 minus x to x. Alright? They also come in numerical form. Also a lot of marks in grade 12 and 11. As high as 9 marks. Why? Because they want to see if you can convert the 480 degrees to something like 360 plus or 360 minus. Because that way, you come back to your range of 0 to 360, which is a full revolution. Anything 361 and above, it's past the revolution. It's a new revolution. So that means you're going to have to reduce the angle to something you're familiar with, which is between 0 and 360 degrees. So the same problems showing up in different grades. All right? So, long story short, I don't want to do that investigation just yet. I'll do it in another class, and I guess that will help you also refresh your memory. But I'll do it in another class when everyone else is here, since I don't think everyone will get the recording. Or will get the recording but will not benefit from the live teaching. Anyway, so if we have sine of 163 over cos of 197, and we have to add it to tan of 17, and we must add the cos of 180 degrees minus theta and multiply that by the tan of 180 degrees plus theta. Ne? So we've got a mix of numerical expressions and non-numerical expressions, right? So sine 163, we can say it's 180 minus 17. 197 is 180 plus 17. The obvious thing is that the 17 here, ka 10, gives us a telltale yaro. We might need to reverekele angle ya 17 degrees. That's what this problem is telling us. At least it's giving us a hint. And why I'm suggesting that is because when you look at these as well, you'll find that the one small angle measure that you're given, or an angle that will have very funny differences between it and the next known angle being between this and 360. What's the difference? Between 330 and 360 degrees. What's the difference?
Between.
Yeah. Between you're at 330, you want to go to 360.
30.
Yeah, 30, right? Between 180 and 50, what's the difference?
30.
30. So that already gives you an intuitive sense, a sense in your mind, right? Maybe 30 degrees Oh, and guess what? When they solve it, that's the first thing they look at. And when it's 30 degrees, you can use special angles. Yes. You can use special angles. And here we're just discussing how the thinking around solving the problem is. You go to the 751. If you take 270 and you add 45 degrees, 270 over add 45, how much is it?
270 plus 45.
Yeah.
315.
315. So I want to wish a guy. If you take 300 and you subtract 30 degrees, where does it take you?
270.
If you add 60 degrees, where does it take you?
60 degrees, guy.
If we add 360 or 300, okay?
You add
60 degrees to 300.
360.
Over 360. So you got two options there. You got a 60-degree angle or a 30-degree angle, depending on which one you're going to work on. But it would be probably easier to work with 360 because at least you know the conversion, the reduction. Yeah, so this is just how they would show you how the problem statement itself has clues. So you can start by playing on your calculator and say, I've got 17 degrees here. If I add that to 163, how much do I get? If I subtract that from 197, how much do I get? And that now gives you the reduction formula you're going to use. And once you have them, this is a quotient identity, so it's tan. And since one of them is going to be negative, it gives you negative tan 17. And when you add it to plus tan 17, they become additive inverses. And those two, because of dissolving, they'll give you a quotient identity and the answer ends up as negative sign. So we're doing it step by step. If we have sine of 180 degrees minus 17 degrees. And here we have cos of 180 degrees plus 17 degrees. We add that to tan of 17 degrees. And we add that to 180 degrees minus theta is second quadrant. Cos is negative. So we're going to have negative cos of theta. And tan of 180 plus, that's third quadrant. Tan is positive, so we reduce that and it becomes just tan of theta. This here becomes 180 degrees minus, sine is positive, so this is just sine 17 degrees. 180 degrees plus, cos is negative, so that just gives us negative cos of 17 degrees. And then we add tan of 17 degrees. We subtract the cos of theta and we multiply by sine theta over cos theta because tan is a quotient identity. Now this is also a quotient identity. Sine 17 divided by negative cos 17 is negative tan 17 degrees plus tan 17 degrees minus sine theta. These are additive inverses. They are result to 0 and we're only left with negative sine theta. These are the types of questions also where they'll say without using a calculator. Because what's the point? You see? Because what's the point? You'll use it, but and then what? Just even if you had a calculator, you wouldn't be able to solve it because theta is unknown. My wish.
Yeah, I understand.
Yeah. So some examples that we can practice with. We've got, determine the value of the following expressions without using a calculator. Tan 150 degrees times sine 30 multiplied by cos 210. Already here you can see there's a recurring angle here, 30 degrees. Why? Because if you take 180 or 30 degrees, how much do you get? If you take 180 or subtract 30 degrees, how much do you get? 150. So we can at least, before we start solving, try to think about the angle and guess it. So we've got 1a array, the tangent of 150 degrees multiplied by the sine of 30 degrees minus the cos of 210 degrees. Can you be gentle with the movement? My table is not very stable. So when you jiginisha it and I'm writing, then this equals tan 180 degrees minus 30 degrees multiplied by sine 30 degrees minus cos of 180 degrees plus 30 degrees. 180 minus tan is negative, so this gives me negative tan 30 degrees times sine 30 degrees minus 180 plus theta is third quadrant. Cos is negative, so then that becomes plus cos of 30 degrees. Tan is a quotient identity, so that's minus sine 30 degrees over cos 30 degrees times sine 30 degrees plus cos 30 degrees. This is negative. You know what? We didn't even need to go that far. Because it's 30 degrees, we can go to special triangle. 60 degrees, 30 degrees, 1, 2, square root of 3. Right? What's the tan of 30 degrees? It's opposite over adjacent, so it's negative 1 over square root of 3. What's sine 30 degrees? It's opposite over hypotenuse, it's a half. And what's cos of 30? It's square root of 3 over 2. And we simply have square root of 3 over 2 minus 1 over 2 root 3. And if you want to, that goes in 3. And this is simply 4 over 2 square root of 3. Without using a calculator, we got the answer. Yeah, so we can do another one. It's number B. So are you starting to see how we think about some of these things?
Yeah, I see.
Yes. So we can do, what is this one? 1 plus cos 120 degrees multiplied by 1 minus sine squared 240 degrees. 240 degrees is like what? If you have 180 and you add 60, how much do you get?
180 plus 60. 240, I think.
Yes, and if you have 180 degrees and you subtract 60, how much do you get?
180 minus 60.
Yeah.
120.
Yes. Right. So we can have 1 plus the cos of 180 degrees minus 60 multiplied by 1 minus the sine squared of 180 degrees plus 60. Then this one simply becomes 1 minus cos of 60 degrees. And this becomes I wonder if that's correct since it's squared. Yeah. Then 1 plus sine squared is the same as... What did I do? Something is not right. That's fine. Then I can have 1. Oh, I didn't even need to. And I can just simply go back to special triangles here. 60, 30, 1, 2, square root 3. Cos of 60 is 1 minus a half. And sine of 60 is square root of 3 over 2. So this becomes 1 plus 3 over 4. And this is 1 over 2 multiplied by 7 over 4. And this is simply 7 over 8. All right, so all right. All right, I think that exhausts these ones. Then we can look at how to write these that are intricate or complicated as like one trigonometric ratio, single trigonometric ratio. So we have to reduce and simplify. Say, quotient can reduce, then look for identities and then go forward. Yeah? So if we have, in terms of a single and trig identity, in trig ratio, we have tan of 180 minus theta times sine of 180 plus theta. 180 degrees minus theta is second quadrant. Tan is negative in second quadrant, so this reduces to negative tan theta. 180 degrees plus theta is third quadrant. Sine is negative in third quadrant, so this becomes times negative sine theta. Tan is also a quotient identity, so this is sine theta over cos theta times negative sine theta. Is this okay? Doesn't look like it, because now I've got sine squared over cos, and that kind of doesn't solve the problem. I'll have to think about it again. Yeah, 180 is third quadrant, so it's negative tan theta. 180 plus, so it's negative sine theta. Can I do this one? Nope, it's not gonna work. Okay, I'm not sure about this one, but can we pin it? We'll just pin it for later discussion. B is tan of 180 degrees plus theta, cos of 180 degrees minus theta, and this is divided by sine of 180 degrees minus theta. And this is, in third quadrant, tan is positive, so this is simply tan theta. In second quadrant, cos is negative, so this is times negative cos theta. And in second quadrant, sine is positive, so that's sine theta. Negative cos divided by sine, or rather let's say sine theta over cos theta times negative cos theta over sine theta, and this equals 1. Ooh, I see. Here's what we can do here, because I think I was right with co-function. Hear me out. Oh, sorry, reciprocal. So since this is going to be sine theta squared over cos theta, because tan is sine over cos, and then you're going to have sine times sine over cos. This is the same as 1 minus, wait, it's not exactly like, okay, and this becomes 1 over cos minus cos squared theta over cos. No, this is not working out. As one trigonometry ratio. 8, yeah, no.